Here is today's agenda. First is opening by the moderator. Second is short speech from Mr. Bambang Smedi. Third is lecture by Dr. Yeny Nadira Kamaruzzaman. Fourth is question and answer session. And the last is closing. Now it is my honor to invite Mr. Insinyur Bambang Smedi MSc PhD to represent Graduate School of Universitas Brawijaya to deliver the opening remarks and introduction of this visiting lecturer. Please give warm welcome to Mr. Bambang.
Okay, thank you, moderator. Good evening, everyone. I will just give a short speak briefly. First of all, I would like to greet my college, respected Dr. Yeny Nadira Kamaruzzaman, Professor Kwan Sun Chang from MUST Taiwan, Dr. Wu from LNA Taiwan, and then Dr. Mubarak from NTOU Taiwan, and also my friend Jacinto from Timor-Leste. Yeah, thank you very much for your time and support. Currently, we are implementing the visiting lecturer program of Brawijaya University. This program aims to improve academic quality research and expand UB Global Academic Network through collaboration with qualified international scholars. The objective of this program are first, to provide UB academic community with global perspective, and then to increase the number of journal, the quality publication in reputable international journal. And then the last one is to strengthen UB academic network at international level. Finally, good luck following this lecture until the end. Hopefully it will be useful and will for all of us. Thank you very much. Okay.
Thank you, Mr. Bambang Smedi, for your introduction and warm speech. Before we move to the next session, there will be documentation guided by me as the moderator. For all participants, please turn on your camera and give your best pose for this session. Now we will begin the documentation. Please turn on the camera. I will count into 3. 1, 2, 3. Okay. One more time. 1, 2, 3. Okay. Thank you. Before we will now move on to the main session throughout this lecture. Feel free to take notes, ask questions, and participate actively in the discussion. Before we begin this lecture, it is a great honor to introduce Dr. Yeny, who joined us today as a visiting lecturer. Dr. Yeny is a senior lecturer at the Faculty of Fisheries and Food Science, Universiti Malaysia Terengganu. She holds a doctorate in ocean science and has built a strong academic and research profile in the field of fisheries oceanography. Her scholarly work focuses on the impact of climate change on marine ecosystem, particularly pelagic fisheries, employing advanced methods such as ecological habitat modeling, remote sensing, and GIS. We are privileged to welcome her and look forward to the valuable knowledge and expertise she will share with us. Now, without further ado, we are pleased to introduce our speaker for today, Dr. Yeny Nadira Kamaruzzaman, PhD, as a senior lecturer, Universiti Malaysia Terengganu. To Dr. Yeny is welcome to present.
Okay, Assalamualaikum and a very good evening. Thank you, Gina, for the introductions. So today lectures is going to take around 90 to 100 minutes. So feel free to make yourself comfortable because it's going to be a long lecture. So I divided this lecture into two parts. Okay, there's two parts, and a part 1 and a part 2. So each part approximately around 45 minutes and 45 minutes. Okay, so Gina, are you going to share my slide for me? Or I share it myself? Or Gina share?
I'm sorry, Dr. Yeny, I don't have the PPT already.
Itu ada.
I'm sorry.
Okay. Tak apa ke? Ada share kan? Boleh ya? Sebab I don't know how to share the slide. Okay. So today's lecture title is Sustainable Fisheries in Changing Climate. So the role of machine learning and also remote sensing. Okay, so next. So just a bit of introductions about myself. So my name is Yeny Nadira. So I did my bachelor in Applied Science Fisheries in Universiti Malaysia Terengganu, where I work now. So, and then I pursue my master's in marine biology, which I did my master's in Bangor University in the United Kingdom. And then after finish my master's, I did my PhD in ocean science in Universiti Kebangsaan Malaysia, which the University of National Malaysia. Okay, so I just finished my PhD around 2020. So approximately I just worked almost 5 years. So it's still in my early career research lah. Okay, so continue. So for the part 1 is remote sensing and oceanography for fisheries prediction. So we are going to start with introductions about Southeast Asia. Okay, so we focus on Southeast Asia. So as we know that according to FAO, so the major fishing areas is actually in the Southeast Asia. So the countries in the Southeast Asia regions are among the world highest producers of fish and also fisheries product from captured fisheries that come from the water identified by FAO fishing areas lah. So you see that 61, 71, 57 is the major fishing product areas. So the global total, so in the whole world, the global total production is approximately around 182 million metric ton. But from Southeast Asia alone, we contribute around 45.8 million ton, comprises of marine captured fisheries, inland captured fisheries, and also aquaculture. But Indonesia specifically contribution very big, approximately around 22.3 million, making it the largest producers in the region. Okay, so next. So we already see the major fishing area, so we focus more on the Coral Triangle. Why Coral Triangle? Because Coral Triangle is a marine area which is located in the Western Pacific Oceans, and it includes the waters of Indonesia, Malaysia, the Philippines, you can see in the photo, Papua New Guinea, Timor-Leste, and also the Solomon Islands. Okay, so this area consists of 76 of the world coral species, and also 37% of the reef species are found in the Coral Triangle. So this area, it provides a very critical habitat for the pelagic species, particularly for tuna, and then we have sea turtles, we have marine mammals, and also invertebrates. And this area ensure ecosystem stability and also resilience against the climate change impact like bleaching and also ocean acidification. Okay, so next. Okay, so this area, particularly it supports, previous one. Okay, it supports over, before, the slide before. Boleh? Okay. So they support over 120 million people who depend on this coral area. So it's directly or indirectly on the marine resources. So this area produce more than 4.3 million tons of fish annually. So it contributes significantly to the food security and also export revenues. And also this area is a vital spawning and nursery ground for commercially important species like mackerel, tuna and sardines. And also other than that, it also generates billions in tourism revenue through diving, snorkeling and also recreational fishing. That's why many people like to come to Southeast Asia, particularly in Indonesia, in Malaysia, okay, for diving and also snorkeling to enjoy our beautiful country. Okay, so next. So this area, not just the unparalleled ecological and economical benefit, tapi dia juga supporting rich marine biodiversity, enhancing regional food security, and also protecting the coastal communities and buffering against the climate change. So actually the Coral Triangle is the backbone of sustainable fisheries in the Southeast Asia. Okay, so in this area, fishing is, as we all know, fishing is an essential source of income and food for the people that live in the Coral Triangle. So however, fish are being depleted. Okay, we harvest the fish beyond levels which population can recover or even the reef can sustain. So in the last 40 years, okay, 40 years ago, world fisheries production rates has declined. So menurun, have reduced 80% due to overfishing pressure and also habitat change and also pollutions and also climate change. So scientific evidence has demonstrated that several importance of fish stocks are already fully exploited or even overexploited. For example, the global demand for tuna drives the fishing industry to harvest at unsustainable level. Okay, and it has led to alarming decline of tuna stocks in the Coral Triangle. So other than tuna, grouper and snapper also are being depleted as well. So next. Okay, so the history of overfishing. So it started from the 1690s. The global capture rate produced about 330 million, and then after that the fishing expanded due to industrializations and also new technologies. And in the 1970s to 1980s, there's a rapid growth in catch from trawlers because of new technology like sonar and also cold storage, and the expansion into the deep sea and the high sea. So the production reached around 90 million tons by the late of 1980s. But since 1990s and present, the total production stabilized at 86 to 95 million tons per year. But the sign of overfishing have become clear. So many key species like cod, herring, anchovies became overfished. And now currently the global captured production is approximately around 91 million tons, with captured fisheries around 79.7 million tons. And the top producers is from China, Indonesia, Peru, Russia and in India. Okay, next. Okay, so other than overfishing, okay, so the current level and also the methods of harvesting fish and other resources are not sustainable. So overfishing, destructive fishing method, non-selective fishing gear, all these harm and fragile the coral reef and also devastate fish and other marine animals populations. So in the photo, other than fishing, bycatch, oil spill, microplastics are also the global threat to the marine ecosystem. And other than that, we also have a growing populations and also the effect of climate change, coastal development, also a threat, not just Coral Triangle, but the whole world in general. Next. Okay, so as we all know that the oceans around us is very dynamic. It changes every day. Like today's raining, tomorrow is sunny day. So even the oceans also can be very dynamic, and nowadays we can see that the oceans around us is changing. Okay, for example, Malaysian artisanal fishermen are beginning to suffer the impacts of climate change, while include more frequent extreme weather, changes in fish species availability and behavior, and also sea level rise. Okay, so some fishermen say that in the morning they can go to the oceans, and when they come back they cannot because of rain in the evening. So it's very difficult to predict, not just in Malaysia. Meanwhile, in the waters of Philippines also, the fishermen agree that the typhoon have become more frequent. You know, in the Philippines, the typhoons always occur, not just more frequent, it becomes more violent, okay, due to the effect of the climate change. And the weather now has become so unpredictable. So according to Chong et al., it said that tropical oceans are expected to suffer most from climate change on fish stocks. So countries in the region also are very highly dependent on fisheries, because you know that the changes in temperature, the temperature become more increased, okay, due to the warming of the sea, especially in the shallower coastal water. Heat waves occur more frequently, and also which causes the corals to die due to the increased temperature, and also the acidity also increase. Okay, the sea also absorb much of the additional carbon dioxide, okay, which leads to acidifications. And also we know that the oxygen content in the water also decreases. So what are the causes of these changes in the ocean? What is the causes? And then how these changes affect the marine fish stocks and also fisheries, and how these then affect the well-being of people, and what are the solutions to this problem? So next. Okay, so I think by now we all know that the number one cause of climate change is due to human activity, because human generates greenhouse gases by burning fossil fuel that contribute to the global warming, that includes the oceans. It comes from fossil fuel, coal, oil, gas, industrial processes, deforestations, and today 30 billion tons per year of carbon dioxide, or around 84%, okay, is related to human activity. So one of the consequences of this is that it leads to a reduction in the amount of oxygen in the water. So when increases atmospheric carbon dioxide, it will trap the heat, so it will drive global warming and ocean heating. So also carbon dioxide will drive the climate crisis and also affect the oceans, making them 30% more acidic than the current water. And then marine fish and many other marine life are very sensitive to these changing oceans conditions. So the main effect is the sea surface temperature will become rise, coral bleaching will occur, and also it will alter the fish distributions. Okay. Next. Okay, so climate change effect on the coastal ecosystem. So we know that the causes of the burning fossil fuel, deforestation, industrial agriculture, release carbon and other heat trapping gases in our atmosphere that causes our planet to warm. So the oceans contains of 70% of the world surface, has buffered us from the worst impact of climate change by absorbing more than 90% of this excess heat and about 25% of the carbon dioxide, but at the cost that will significantly harm the marine ecosystem. So not only the ocean water warming, but they also absorb carbon dioxide. So greenhouse gases that contributes to climate change. So the carbon dioxide will alter the ocean's pH balance, which making it more acidic and toxic to some marine organisms. So the impact is it will causes the coral to bleach, ocean acidifications, sea level to rise, harmful alga bloom, toxic algae, and also habitat and fisheries disruption. Okay. Okay, so climate change. We're talking about climate change. So since overfishing occur, so many fish stocks are already exploited to their limits. Okay, so extra stresses from climate change could cause more serious problem. So most of marine fish live and breed in the shallow coastal water, which are the area that were most affected by changes in temperature, ocean currents, which is upwelling, and also food supply, which is their primary productions. So the climate has a big impact on the juvenile fish in the coastal and also estuaries areas. So it will affect their growth, their numbers, and also their survival. So which can affect overall the fish populations and ecosystem. Next. Okay, next. Okay, so other than climate change, also ocean acidifications. So we know that the ocean absorbs carbon dioxide. So carbon dioxide, when mixed with water, it will become more acidic. Okay, the increased carbon dioxide dissolved in seawater will form a carbonic acid, which is increased acidity. So you know that coral reef and also other invertebrates the hard exoskeleton is made by carbonate. So carbonate used by the coral and shellfish to build the hard exteriors becomes scarred when ocean acidity increases. So because many reef animals rely and live on coral reef for food and also for shelter, changing ocean chemistry can affect the entire coral ecosystems. Okay, so it will weaken the coral skeletons and also shell of the marine organism, especially like mollusks and plankton, and at the end it will disrupt the food chain. Okay, next. So as we know that shellfish and coral are extremely vulnerable to ocean acidification because it interferes with their ability to form the hard skeletons. So reef building corals cannot survive if the water keeps warming. So coral rely on algae living inside them to supply them with food, and these algae, which create the brilliant color of the healthy coral, die if the water gets too hot. So the loss of the algae leave the coral with a bleached appearance, and then at the end leads to starvation. So widespread of coral reef bleaching, sea level rise, and seawater acidification, endangered marine animals like reef fish and marine turtles, and then suddenly will negatively impact the local livelihood, such as fishing and tourism. And also it will threaten a critical supply of protein. More than 100 million people will be affected. Okay. Okay, so how is climate change affecting the food supply of seafood? Okay, so climate change will affect wild fisheries. Okay, we're talking about the fish in the ocean. Okay, by changing their productivity and also shifting where the fish live out of the oceans. So among other factors, these characteristics determine how much we can sustainably harvest. So what we expect to happen is that the fisheries will shift towards the pole, which is the cooler area, okay, and to track the fisheries' preferred temperature. Okay, next. Okay, so in this figure, you see why the Chang said that the Southeast Asia is the most at risk for climate change, because our area is already hot. So the tropical oceans are expected to suffer most from the climate impact on the fish stocks, because earlier IPCC reports that already identify Southeast Asia as among the world's most at-risk region for extreme climate event. Okay, so the tropical ecoregion in Asia, the Pacific, South America and Africa are experiencing declining fish populations as the species move further north cooler waters and are also to unable recover to fishing demands. You see in the red area, so when it becomes hotter, the fish will go to the blue area. Okay, it will migrate to the cooler area. Okay, so this is because climate change has caused variation in marine factors such as elevated temperature, sea level rise, pH, rainfall, ice melting at the poles, and also change in the wind speed and also directions. So all these changes in the oceans are already affecting the fish stocks and fisheries all over the world. Thanks. Okay, as you can see, elevated temperature, the climate change will cause an increase in the sea surface temperature. So it will affect distributions and also the abundance of the fish populations. So in the tropical ecoregions, especially in our Southeast Asia, are the ones that feel the effect of global warming first. Okay, and studies showed that even a slight increase of 1.5 degrees Celsius could have a catastrophic effect on the tropical nations. Okay, the most significant impact of elevated temperature, that means increased temperature on the fish population, is in the change of their distribution patterns. Okay, so the temperature, even as small as 1 degree Celsius, can have an effect on their geographical distributions. So the most tropical marine has extensive latitude range capable of further extending the temperature gradient up to 3 to 4 degrees. For example, I give you like Indian mackerel. So Indian mackerel, optimal temperature is around, let's say 20 to 30. So it can expand their range 3 to 4 degrees, but that's all. And after that, of course, they will move. Okay, so some species may benefit from the shift towards the environmental condition outside their normal range of variability, but in most conditions, these environmental changes will change peak fishing season and distributions of prey and prey predators relationship. Okay, so the range limit may increase or decrease depending on the heat tolerances of a species. So if you see at the photo, elevated temperature could change so many things. Fish survival, fish death, spawning, their growth, their feeding, their metabolism, and also their spawning, their migration, their distributions, and also their abundance. So many things that could happen due to the elevated temperature. So next. Okay, so here I give you 3 examples of the pelagic species. So each species, all species is not the same. Okay, they have a characteristic of each species. So, sardines. Sardines schools are commonly observed caught near oceanic front. Okay, so their distribution change with the seasonal movement of this front. Okay, and the position of the front and the thermocline significantly affect the sardine distributions. For mackerel, so this species is fast swimmer, okay, and they form a large school. So these mackerel will migrate seasonally and geographically in response to their ocean reproduction cycle, currents, and also circulations. So studies indicate that potential fishing ground are located from near shore to offshore or area, and these species tend to aggregate based on the physical and biological oceanic conditions. And for tuna, usually tuna prefer more cool areas. So the biophysical environment of transition region is significantly influenced tuna distributions and abundance. So tuna migrate and availability are closely linked to oceanic fronts and eddies as well. So the frontal zone, eddy field and topographic features are critical habitat hotspots for pelagic fish like flying squid and also tuna. Next. Okay, so what is pelagic hotspots? We already see that each species have different biological and physical condition characteristics. So with understanding these biological and physical understanding, we can predict or we can locate the pelagic habitat hotspots. So what is pelagic habitat hotspots? They are defined as an area with high biological activity where linkage occur between physical processes, primary production, secondary consumer, and higher trophic level predators play an important role in controlling distribution, migration, and abundance of the commercial and wide roaming pelagic species in many different oceans. So large pelagic fish as well as the commercial fishing vessel recognize the prey organism aggregate at the ocean hotspots. So usually if you are experienced a fisherman, you can easily locate actually, okay, because it's predictable, okay, and mostly represented by the ocean front. If you can locate the ocean front or the upwelling areas or the eddies, this is where usually the fish will congregate or aggregate at the area. So ocean fronts are important congregating spots for the many valuable pelagic species. So front consequently have an immense effect on the oceans. So actually by using sea surface temperature and also chlorophyll, you can identify the habitat hotspots. For example, and the photo shows that the spatial distributions of the pelagic hotspots for skipjack tuna. Okay, this one in May. Okay, frequency for 5 years in the southwestern coral triangle tuna Indonesia, and the geographical relationship between average CPUE. As you can see, high CPUE will locate at the red and yellow area. Okay, next. Okay, so how do we locate this area? So usually we will use the biological and the physical oceanographic conditions. Okay, so to understand the fluctuation in the commercial fishery stocks, the process that affect the distributions, the abundance, migration, and recruitment of fish in the context of biotic and biotic environmental variability need to be understood. Okay, so the spatial structure and the distributions of pelagic fishes depend on their environmental conditions. So usually we use SST and chlorophyll are the parameters that were often used, okay, to explain the distribution and abundance of the fish based on the catch per unit effort. And a variation of these two factors were used to identify aggregation area and also the potential fishing zone. So as you can see that the monthly, in the photo, we have wind and the upper one, and then in the middle one is the SST, and the lower one is chlorophyll. So monthly mean wind stress at the top, sea surface at the middle, and also chlorophyll at the bottom for the months of February and also August to represent the northwest and southeast monsoon respectively. So okay, next. Okay, so why we use these two variables? You can use as many as you can, but usually two is the main one. So SST, why we use SST? Because SST is assumed to be an index of the physical environment, which it influences the phytoplankton growth. And also we know that temperature controls the physiology of the living organism, such as spawning, aggregating, and also migrating period. So it is also known that SST play a key role as the only environmental predictor highly related to diversity of many pelagic fish. So even if you do in aquaculture also, it's very important for you to make sure that the temperature is within their range, right? Okay, so same with the fish in the ocean. And other than that, we also have chlorophyll concentrations. So why we use chlorophyll is because it's a convenient index of phytoplankton biomass. So, and it is the most important pigment required in the photosynthesis process. Okay, so it is very important oceanographic parameter in determining the productivity of the ocean and often relate to the fish production. So the higher the chlorophyll, so means higher is the fish biomass. So the variability of chlorophyll is also related to seasonal monsoon and also interrelated with wind, current, rainfall, and also river discharge. Next. Okay, so Chang stated that apparent changes in the captured marine fisheries compositions are related to the changes of the ocean temperature. So variation, perubahan in the sea surface temperature as a result of climate change has affected directly and indirectly on the fish stock commercially. So direct impact is also is causes by the impact to physiology and also evolutions of behavior of the fish growth development, reproductive capacity, death, and also distributions. While indirect impact is changes in the productivity, structure, and fish ecosystem composition where it depends on food and shelter. So modeling approach that are able to do simulations on the species interaction with the environment is needed to understand the impact on species and community further. So in climate change modeling, projected SST is a method that is often used to predict the effect of climate change on the marine species. Next. Okay, so according to the IPCC, the Intergovernmental Report on Climate Change, okay, the global average SST, sea surface temperature, has increased by approximately 0.9 to 1.1 since the beginning of the 20th century. So projected SST increase under different greenhouse gas emission scenario, SST is projected to increase further. So they projected that in SSP 1 to 2.6, which is low emission scenario. So if we low our emission, so there will be an increase of 0.86 degrees Celsius is projected, okay, between 2021 and 1995 to 2014 and also 2081 to 2100. And also in the high emission scenario, that means if we don't control our gas emissions, increase about 2.89% is projected over the same period. So the ability to determine the impact of SST increase and to predict the changes in fishery resources in the long term is vital to guarantee the continuity of fisheries resources and contribute to the effective management. So at the end of the century, if we not control our gas emission, it could warm about 1%, okay, the 0.86, so approximately 1%. If we reduce the emissions by a lot, but if we don't, almost 3% of increase if the emissions stay high. So it's a bit alarming, okay? If the, like I said, temperature, even with slightly 1 degree also can change many things in the fish, in the oceans. So imagine if 3 degrees Celsius, it could have more larger impact. Okay, so next. Okay, so this is where remote sensing comes. Okay, so remote sensing, physical and biological features in real time, okay, can be detected by sensor of satellite remote sensing. Okay, so this technology able to provide us reliable global ocean coverage of SST and chlorophyll at relatively high spatial and temporal resolutions. So which it can measure from space. Just imagine you don't need to go sampling, take water sample just to check the SST and the chlorophyll. We can do it online, just at the end of your fingers. Okay, so this is an effective and efficient way to compare with field sampling that required time. Okay, if you go sampling, you will require your time and it will require more cost and also limited coverage area. So that means if you go sampling, you can only limited time and limited space. But with remote sensing, it covers the whole world coverage. Okay. So next. Okay, so remote sensing is actually a process or a technique in obtaining information about an object. It doesn't have to be the oceans. All things can be detected by remote sensing. Okay, an object, an area or phenomenon through the analysis of data by collections by recording, observing or viewing objects from a distance, okay, by using electromagnetic radiations as a carrier of information. So remote sensing satellites are an important technique in fisheries research, management and catch because it provides synoptic oceanographic measurements to assess the influence of the environment on the abundance and distributions of the fish populations and facilitate analysis at the community and ecosystem level. So remote sensing technology is suitable to collect data in a large area and it can be done repeatedly in a short time. Okay. So next. Okay, so other than remote sensing, we must use GIS. So what is the Geographical Information System? So the availability of high resolution remote sensing data along with GIS technology has made it easier to observe the key oceanographic parameters over space and time. So GIS is widely used in marine fisheries to study the relationship between fish population, dynamics and also environmental factors such as temperature, currents and chlorophyll. But GIS is not just for marine research. They use it for many things, okay? Even in the forest to locate the elephant, the tiger also use GIS. Okay, so GIS help to process the satellite image and support spatial analysis by combining oceanographic and ecological theories with statistical tools and database. That means you need all these three skills. Okay, so therefore the integrations of satellite image, and then you can have your GIS technology and also your statistical analysis and also in situ observations, I mean your fishing locations, is one of the most effective methods to support the sustainable fisheries management. So next. Okay, so why we need to know or predict the pelagic hotspots or knowing fish distributions and abundance? What are the advantages? So we know that fish are known to find a suitable habitat for feeding, spawning, migration and protections. So distributions of pelagic fish, which is a complex phenomenon. That means they must have a certain range of temperature, a certain range of chlorophyll to found the aggregating areas. So this complex phenomenon is controlled by the interactions of several factors in the marine environment. So this complexity makes it difficult for fishermen to determine the potential fishing ground. So the majority of the fishermen apply traditional methods to locate potential area for fishing activities. So the search, okay, ends up in a lot of resources and time being spent, thus resulting in increase of cost, but low profits. So by predicting the fisheries hotspots, we can improve the fishing gear efficiency. We can determine the potential fishing ground more quickly and more accurately, and then we are going to help the fishermen to exploit marine resources more effectively and efficiently. And also we can promote sustainable fishing. We can reduce in searching time, which will increase catch with lesser effort, and also critical for marine management strategies and identifying potential targets for conservations. Let's say if we know that the certain fish at a certain time, we can make a seasonal closure, or we can make more marine conservation area due to the spawnings area, something like that. Okay, so that's all in part 1. So I think we can do end of part and then Q&A and another part Q&A. So is there any question in the part 1 before we move to part 2? If there's no questions, then maybe we can take like 5-minute break and then we continue with part 2. So how?
Any question, Ina?
Yeah. Oh, am I talking too fast? Is it clear for everyone?
Mr. Mubarak, do you have any question?
The students can understand me. That's the most important thing.
Yeah. Hi, Professor.
Hi.
Yeah, can you hear?
Mubarak.
Yeah. Hi. Yeah. Hi, Dr. Yeny. Yeah. Nice presentation. So yeah, I have one question regarding you mentioned about the ocean acidification and the coral bleaching. How it related? Because I'm also working in the remote sensing using the fishery data and the oceanographic data. So how we can incorporate to connect with the pure climate change, the facing the ocean acidification and the coral bleaching. So which data we can incorporate to connect with the fishery, to connect to analyze the direct involvement to connecting the ocean acidification or marine heat waves, something like that. Yeah, thank you.
Okay, thank you Mubarak for the question. Okay, for ocean acidification, remote sensing and GIS also has been widely used for mapping the coral reef area. So it has to do with SST as well. That means maybe if we can predict the high temperature during a certain times, El Nino, La Nina, something like that, it can affect, usually during ENSO, right? Will occur the coral bleachings like in the Great Barrier Area, Great Reef in the Australia. So maybe with that, using the remote sensing as well, we can predict where the next coral bleaching area will occur. Usually because, coral reef at a shallow area, so they are more highly will be affected by the increase of temperature. So with that, maybe we can predict using the SST. Yeah.
Yes.
And because many also researchers have using GIS and also remote sensing in mapping the coral reef.
Okay. Thank you.
Thank you. Okay, I think there's a question here. Is it possible for local fishermen to predict sea surface temperature? What simple technology can use to predict? Fisherman is actually a very expert. Okay, I'm not usually go to the ocean, but there's a few times which I go to the ocean. So most fishermen, they know where the fish is using their experience. They repeatedly every day for 20-30 years they go to the ocean. So just by feel the wind or seeing at the current movement, they can know where the fish is. But how they cannot predict the sea surface temperature. That means they have to see at the sonar, or they can feel the water, but they cannot predict the seawater temperature. And the only thing to predict SST is using remote sensing. But we do not underestimate the fisherman knowledge. Okay, so usually they use their repeatedly experience by seeing, you can see that if there's a fish down there, you can see the bubbles, or something like there's a bird, and then sometimes they can see floating, the fish will usually below the floating area, like fish aggregating device. So fishermen actually know where is the fish located, but that is only from their experience, not from their knowledge, like why is that. Okay, so the fishermen cannot predict sea surface temperature, but they know where the fish is usually. But because of the weather is changing, so it's a bit complex, especially if you're a new fisherman, and maybe it becomes difficult for you to see or to predict where's the fish. But usually the experienced fishermen, they know where the fish is. Okay, is there any question? Any question more? Thank you, Fitri.
Okay, sorry, I just to add the answer of Ibu Fitri, yeah, this is possible to the local fishermen. The technology can use to predict. Usually, as Ibu Yeny told you, in a very simple way, usually fishermen use hand touch, like that, yeah. Yeah, our local fishermen, especially around Java Island, they use hand touch. So they can predict, but yeah, of course, there is no exact value of SST. But yeah, this is very simple. Yeah, very simple. They use hand to touch the water.
Yeah, they use hand. Yes,
like that.
Sometimes they will try just to touch the water and feel the water, they already know. Or sometimes they see where the wind blows, actually they already know where's the fish. So, but it takes experience. So maybe the 20 or 30 years fishermen, they already know.
Yeah. Okay, thank you.
Correct. So can we take 5 and then we continue back for part 2? Maybe we can take 5 minutes. So you can take your water and go to the toilet break.
Okay.
Okay.
Okay, good evening, Professor Chang from Taiwan. Thank you for you joining.
Hello, everyone. Thank you, Professor Bambang's invitation.
Thank you. We just have one more lecture from Dr. Yeny. So it's actually we need. Do you have your student join in this room? No.
Bambang, you mentioned my bachelor program students in maritime engineering bachelor programs.
Yeah.
Okay, I'm not sure for that. Actually, I passed your link to their line group, but I don't know.
Okay. Yeah.
Now I
Thank
still
you.
searching. Maybe
Yeah.
they have someone to join today's lecture.
Okay. But anyway, thank you very much for you joining.
Okay, so can we continue to our part 2?
Yes, Dr. Yeny, you can continue to the part of the lecture.
Okay, so this is part 2. Okay, so the part 2 title is machine learning and predictive modeling for sustainable fisheries. So this part is a bit technical. Okay, so next. Okay, so a bit of introduction. So marine, freshwater fisheries and aquaculture have played an important roles aside from food and nutrition service, but it's also a source of profit for 820 million population all around the world. Okay, so with this scenario, effective management of the region's inland and coastal area, as well as its oceans, is therefore necessary to enhance the production trend of fisheries and aquaculture in Southeast Asia to ensure the food security for peoples not only in the Southeast Asia region but also in the whole world. So efficient fisheries management is very essential to make sure that our resources is sustainably exploited. Okay, so sustainable and productive fisheries will help us to improve our food, our nutrition security, and also it can help us to promote economic growth. Okay, so next. Okay, so like we talked about in the part 1, so the fishing grounds are still determined by traditional hunting method. Like I said, usually fishermen will based on their repeated experience as well as gathering information from fellow fishermen. So on the other hand, the spatial structure and also the distributions of the pelagic species is not random. You know that the fish is not just here and there. There's a reason why they are here and there's a reason why they are not there. Okay, so they are particularly vulnerable and change rapidly in accordance with their dynamic environmental factor. Okay, so and the global changes resulting in a distinct distribution and assemblages. So that's why we can predict where's the locations. So because of this complexity makes it more difficult for fishermen to determine the fishing ground. So next. So today, modern fish surveys and environmental indicator. So modern fish survey methods like we use in the remote sensing, also GIS, makes it easier and more accurate to predict the fish distributions in the short term. Okay, so this method required less effort and provide more reliable result. Okay, especially in tracking the sea surface temperature. So the presence of the small pelagic fish can be predicted using two. So physical indicators, which is sea surface temperature, and also biological indicators, which is chlorophyll or phytoplankton. Okay, so the upper ocean processes also like currents and temperature can affect the biological activity, which resulting in influences where the fish are found. So next. Okay, so this is where GIS and remote sensing in marine applications. So advances in satellite remote sensing of the oceans have expanded our knowledge of oceanographic phenomenon at spatial and also temporal scale. So previously in past 40 years, they cannot have this data, okay, from ship and from buoy platforms. So satellite remote sensing data in the oceanographic work is mainly from SST, ocean color, and also ocean altimetry. So application of GIS and remotely sensed imaginary and statistical modeling in fisheries oceanography are also widening the scope of marine studies in space and time. So next. Okay, so GIS, so originally for land use. So many people use GIS to do mapping of the land, mapping of the forest, mapping of the mangrove areas. So it also has evolved to support oceanographic studies. So by handling the dynamic and multi-dimensional marine data. So by combining the remote sensing data with fisheries data in a GIS environment helps to reveal the relationship between marine organisms and also their environment. So GIS and geostatistics allow integrations of various data types to support marine resources planning and sustainable management. So next. So in this lecture, I will share you a case studies, okay, for you to refer. But also there's many studies that have done remote sensing and GIS. So this is just two which I compare. Okay, so we use Indian mackerel. Okay, so the Indian mackerel distributions and abundance. So we know that the pelagic fish live and feed near the surface of the oceans and highly migratory. That means they move from one place to one place seasonally, and transboundary. That means they know bound. Okay, so the Indian mackerel, why we use Indian mackerel? Because it is one of the most abundant and commercially important small pelagic fishery resources in the Southeast Asia. Okay, so the Indian mackerel are highly migratory epipelagic fish, and this species is a surface feeder which prey primarily on phytoplankton and zooplankton and also school by size. That means usually they are in a large group. Okay, so the schooling indicates the presence of a large number of fish, which will be a good fishing ground for a fishing activity. So next. So in these studies, I have two studies areas. So one is in the Spermonde waters, epipelagic waters of Spermonde, and also I compare with Malaysian Exclusive Economic Zone of South China Sea. So in the Indonesia, so one of the large contributors of fisheries production in Indonesia. So this area located at the southern part of Makassar Strait, and it is strongly influenced by the Asian-Australian monsoon. Okay, and this area are also the main pathway of mean flow between the Pacific Oceans and the Indian Oceans, known as the Indian Through Flow, ITF. Okay, so the interaction between the monsoon and the ITF affect the current circulations, heat transport, tidal mixing, wind-induced upwelling and downwelling, and also the environmental variability of chlorophyll, concentration, SST, and salinity of the area. So meanwhile, in Malaysia, the EEZ part of the South China Sea is influenced by the East Asia monsoon season. Okay, so the monsoon wind play a great role in the seasonal monsoon that occur annually in this area. So which include the southwest monsoon from May to September and northeast monsoon from November to March, and the transitions monsoon is between April and October. So currently in Malaysia now is a southwest monsoon. Okay, so this monsoon characteristic influence the oceanographic processes and thereby affecting fish capture and landing in this region. So next. Okay, so even though we have two separate areas, but actually the method is the same. Okay, so we need to have a GIS data type. Okay, so in GIS, you need two types of data. So one data is your vector and one data is your raster. Okay, so a vector data is actually a data type that represent the real world features. That means it's either a point, a fishing point, fishing location, or a building. So there's also a line, a contour, or road, or a polygon. Okay, so like a marine protected area or car park. So this is your vector. Okay, as you see in the photo, that's your vector. Okay, so if you have a fishing location, that means that is your vector. And then the raster data represent the real world features as grid. Okay, so which it store values that are used to interpret the real world feature. For example, you have your SST data. your chlorophyll data, your SSH data. So that is your raster. So both data format are useful in the GIS in different scenario. So it is important to point out the differences to make the usage in the subsequent session convenient. So next. Okay, so there are several types of image processing and GIS software available that can be used to analyze remotely sensed oceanographic data. So some are commercial while others can be downloaded. So if you want free, you can use QGIS. Okay, so usually RGIS you need to pay, and then there's AirDAS imaging and also ETC are some of the commercially available software capable of working with remotely sensed imagery. So on the other hand, the generic mapping tools GMT, CDAS, and GRASS are freely available for download from the internet. So from the photo, you can see that you have your vector and your raster photo, your data perikanan, that means your fishing locations, and also your raster. So you can pinpoint your locations in your raster and you can extract the value. So you can extract using your GIS, and then the data you import into the Excel or you put in a R for your analysis, and then you have a map of a suitable habitat or your and your statistical. Okay, so next. Okay, so this is your fisheries data. What must have in your fisheries data? So fisheries data are useful mainly indicating occurrence and abundance of a species in a certain area. So fisheries data and satellite-based chlorophyll or SST data for a certain period of time were used in this study. So as you can see in the photo, a sample of fisheries environment database showing the spatial information. That means must have your latitude, longitude, and also your temporal information, which is contained in your year, your month, your day, and also your fisheries information such as your catch per unit effort, and also the environmental information that derive from the remotely sensed image, like your SST, your chlorophyll, your SSH. So these you compile in your Excel sheet. Okay, such database is used for modeling the habitat condition of the species under the study. So by mapping this data onto remotely sensed image at corresponding time scale, they can reveal the condition which the catches will make. So they will also can be used to make a generalized additive model from which ranges of the habitat variable important for the mackerel habitat will derive. So that means you have to have your complete Excel sheet before you put in your statistical analysis. Okay, next. Okay, so this is how you download your remotely sensed environmental data. So in my study, I used 3, which is I use SST, chlorophyll, and SSH were used. So each of these variables can be important indicators for the habitat of pelagic species. And there are different ways of analyzing satellite data given by the spatial and temporal resolutions. So it depends on your study. There are daily data, there are weekly data, 3-day data, and they have monthly data. Okay, so considering the temporal scale, one way would be to be used individual satellite passes for a certain variable which can differ, okay, from hours to days depending on the repeated cycle. So other way would be to work with temporally average data. So either daily, either 3 days, 7 days, 8 days, monthly, depending on the objective of your study. So by averaging is commonly used to minimize instances of missing data. Usually if you use a daily data, basically maybe some of the data will have cloud cover. So that's why basically we use the average data to reduce the missing data due to weather conditions, cloud or rain or instrument malfunction. Okay, next. Okay, so for example, In my study, I use the remotely sense graded SST and chlorophyll from MODIS measurement. I use daily level 1 kilometer SST and chlorophyll, which I download from the Ocean Color website. And also I have CDAS version 6.1 we use to extract and process the satellite data. So the data were then subset according to the study area using AirDAS. So meanwhile, daily SSH were downloaded from the NOAA Coast Watch. Okay, so the data were derived from Aviso satellite with resolution 0.25 degree. So as you can see, my SST chlorophyll photo and SSH photo is not the same resolutions. So we need to do a resampling. The image resolution is an important step, especially in cases where the data set used have these different spatial resolutions. So by harmonizing the resolution before analyzing the data further, ensure that the pixel value for all image have the same dimensions. So how to resample the data? You can resample by using CDAS, or you can use your ArcGIS or your EDAS images. QGIS or Python also can. So next. Okay. So the thermal and ocean color front mesoscale phenomenon such as warm and cool eddy and ocean currents are the key features. Like we learned from the part 1, we know that the sardines, the tuna are usually at the front. So what we do is we locate where is the front. Okay, so since the advent of the ocean satellite remote sensing, it is possible to monitor the development of these fishes at relatively large spatial scale and hence assess their effect on the fish habitat. So information from such studies had implication in operational fisheries oceanography and also marine resource conservations. So to enhance our understanding of satellite image interpretation in relation to fish ecology, we first must consider one set of 3 images, SST, chlorophyll and SSH, each of which will overlay with daily resolved fishing location. So next. Okay, so from this photo, you can see that from the first one is the SSH photo, the middle one is your chlorophyll photo, and the lower one is your SST photo. So if you look at the SST image, the color coded from blue to red. Okay, look at the SST below. Okay, so the red represent the warm water, while the blue shows the cold water or low temperature. Okay, for the chlorophyll, the same fishing location, your fishing location is the red one. Okay, so the same fishing location are overlaid on a image, a chlorophyll image. So the blue one are the areas this image shows a low chlorophyll, while the green up here showed the red, green to red color represent relatively high chlorophyll water. So fishing location also overlaid on the SST, the upper one. So SSH image. So SSH data are useful in showing your mesoscale variability in the oceans. So these involve the distributions of eddies and also the surface current. So in this image, area with positive anomalies are shown as red to green, the below one, which are likely to indicate a warm core eddies. So usually fish don't like this, okay? But the dark to blue areas indicate area with negative anomaly, which represent the cold core eddies. So from this picture, you can see the spatial distributions of the fishing fleet in overlay on weekly average SST. So if you can see, that means the fishing location, the red one, prefer SST in the blue area. And also for chlorophyll, the green area, and also SSH, the purple to green area, right? Okay, so next. So this is where you need to do your ecological modeling. So your statistical analysis is very important. So there are many different types of models can be applied depending on your objective. Okay, so fish distributions and oceanographic parameters are shown to have a non-linear relationship. So your optimum range of SST and chlorophyll will be suitable for the fish, while if chlorophyll and SST are less or higher than the optimal range, it will be demonstrated as less suitable. So statistical modeling methods have been widely used in describing the relationship between the individual species distribution and also oceanographic characteristic of the environment. So many studies, if you read many papers, they will basically use JLM, and also there is your statistical analysis, but nowadays there are machine learning, which they have MaxN, random forest, boosted regression trees, and etc. So the data that was sampled from the satellite image can be compiled in your Excel, in your data set or your database that describe the condition where the fishing is taking place. So the data from the database can be used to generate the models that provide more information on the habitat of the species in question. Okay, so next. Okay, so here I just in general show to you comparison of these models. So for JLM, is a statistical type that assume a linear relationship between predictors and response variable. So usually if you use JLM, maybe only one or two variables. Okay, so the pros, it's very simple, it's unpredictable, and it's widely used. So the cons, it may not capture the complex non-linear patterns. Okay, for JAM, also a statistical analysis which allow more flexible, smooth non-linear relationship. So the pros, it captures curve relationship better than JLM. So usually in many papers, they will use this both, JLM, JLM. And the cons, it can overfeed and also need more data. So for machine learning, that means a more complex statistical analysis. For example, some study use MaxN, which maximum entropy model. So this one, MaxN, uses presence-only data. That means if your data limited, you have absence and presence and absence, you can use this data to estimate probability of the occurrence. Okay, so the pros that MaxN good with small data and intuitive output. But the cons, it's only work with presence data, okay, not abundance. That means 1 or 0, ada atau tak ada, have or not have, okay. So for random forest, it's also a machine learning, but this machine learning builds on many decision trees, okay, and averaging the results. So random forest handle complex interactions. That means if you put many variables, not just SST chlorophyll, you put SSS salinity, or you play with many variables, maybe this one is a better fit, okay, and it robust to overfitting. But the cons is less interpretable and computatively intensive. So that means if you're doing a PhD, maybe you can use your random forest. And also your boosted regression tree. Okay, so BRT sequentially builds trees to improve predictions. It has high accuracy and handles complex data well. And also, but the cons, because the boosted regression tree, they have many options, so it needs tuning and can overfit if not managed. So his is the simplified comparison of common species distribution used in ecological and research. Okay, so next. Okay, so if your objective of the study, you want to predict species present or absent, you can use JLM, JM, and MaxN. So if your studies are doing modeling species abundance, you can use JLM, JM, random forest, and also BRT. For habitat suitability mapping, maybe you can use MaxN, JM, and BRT. For more complex environmental interactions, you can use random forest or boosted regression tree. Okay, so next. Okay, so after you do your statistical analysis, this is also very important, whether to check your accuracy of your assessment. Okay, so usually we use kappa statistic used to measure your actual data, catch data, and also your predicted fishing area, okay, from your statistical model. So usually prediction accuracy evaluated using the predictive deviance. So that means we measure how well the model predicts the observed data. So your ROC curve assessed to model performance based on the true or false positive. So your AUC is a key indicator derived from ROC curve. So it measures the model ability to distinguish between suitable or unsuitable area. Okay, so usually when you have a data set, for example, you have 100 data sets, you don't use all 100 to do your predicting map or your statistical analysis. Usually you keep 20%. So let's say 80 data is for your training data, 20% is for your test data. So that means you use 80 data to do your modeling and you keep another 20 for your accuracy test. Okay, so the interpretation of your AUC must be higher than 0.75. So that means your model is useful. So the higher the AUC, that means the better your model performance. Okay, so next. Okay, so in the case study, so that means I compare the two. So the Nuden one in the Indonesia, the objective is to determine the relationship between the Indian mackerel with oceanographic parameters. Nudin just used two variables, SST and chlorophyll. And on the one, he want to identify the potential fishing ground in the epipelagic waters in Spermonde from 2008 to 2009. That means he has only 1 year data. So he used MODIS, SST and chlorophyll, and he used JLM and JM for statistical analysis. Okay, so the results, he found out that Indian mackerel prefer chlorophyll at 0.3 to 0.4, okay, and SST around 30 to 31. And he found out that the potential fishing ground map showed that the area with high potential catch located near the coast to offshore, around 3 to 20 meters, with acceptable level of map accuracy around 83.3%. Okay, so in Malaysia, the studies in Malaysia, Indian mackerel, the objective is to model the influence of environmental variables. So we use 3, SST, chlorophyll and SSH on the Indian mackerel from 2008 to 2010. That means 2 years. So in this study, we use SST chlorophyll from MODIS and Aviso for SSH, and we use BRT for statistical analysis. So the result indicate that the potential fishing ground were closely associated with SSH, followed by SST and chlorophyll. So the performance of the BRT indicate acceptable fishing ground with accuracy of 0.75. Okay, so these studies found that the mackerel prefer SSH around 1.1 to 1.3 meters and SST around 29 to 32 degrees Celsius, and also chlorophyll at 0.3 and 0.6. So if you compare, basically the Indian mackerel is at the same area, same variable. So chlorophyll around 0.3 to 0.6, and also SST at around 29 to 32. Okay, so next. Okay, so this is the result. So the model. Okay, so you can see on your left is the potential fishing ground of the Indian mackerel in the waters of Spermonde in April and also in May, and also May and June in your right. Okay, so on your left figure is the predicted probability of fishing ground of the Indian mackerel at the South China Sea on the October, April, August, and also February. So if you can see the white figure, white blank is actually indicates no data or unavailability of satellite data coverage. So if you can see all high catch, okay, is located around the yellow to red figure. Okay, so next. Okay. So in both studies also, they use elevated temperature to predict what is going to happen to the Indian mackerel in increased temperature. So this one figure showed that, in this figure showed that elevated temperatures on this distributions of the Indian mackerel showed that elevated at 1.8. So the A is actually the actual one. The B figure is when I increase the temperature to 1.8. Okay. C is when we increase the temperature to 2.6, and D is the figure FSST if we increase to 3.3. Okay, so as you can see in April, August, October, and February. Okay, when we increase 1.5, it will result on there's a still increased potential fishing areas for the Indian mackerel, except in October. If you see in February, because in Malaysia, February is the northeast monsoon, that means it's still cold. So in cold, if we still increase 1.8, that means it's still within the Indian mackerel optimal range. So there is still Indian mackerel during February if we increase the temperature. But if under the scenario of 2.6 and 3.3, will show that the potential fishing ground for the Indian mackerel is reduced. Okay, and most of the fishing ground area were projected to decline, and it was observed to shift outside the EEZ of South China Sea. Okay, next. So this is also same. The studies from Nordin also increase the SST. So indicate that the Indian mackerel move to the south, heading to the area with suitable temperature. Okay, you can see, you can compare from A figure, B figure, C to D figure. So this is because one of the fish response to temperature change is migrations. So migration for food can also change the habitat of the pelagic. So because Indian mackerel is a migratory species, mackerel has the capacity to adapt quickly to environmental changes, and it is predicted to thrive along with the climate change, although it has a tendency to change its migratory patterns according to the feeding and spawning area. So this particularly worrying because many of the countries in tropical areas are developing countries, and we are strongly dependent on seafood for our livelihood as well as for our nutritional intake. So we also have a lower capacity to deal with these changes in the oceans. So therefore, with regard to fisheries, reducing fishing pressure would be a major step to increase the capacity of fish stocks in order to adapt to environmental changes. So you can see that the fish is migrating to the cooler areas if under the climate change scenario. So next. So basically, changes in the oceanographic conditions will influence the vertical and horizontal movement of pelagic species. Okay, let's say if the surface get too hot, fish will migrate vertically more deeper, because deeper more cooler. Okay, so this fish species will respond, okay, differently to changes according to their habitat preferences. So let's say the mackerel can adapt 29 to 30. So if more than that, it will definitely migrate to other places that more suitable to their temperature. So therefore, it will resulting in distinct distribution and assemblages. So variability in the ocean physical also play an important role in enhancing ocean productivity and creating availability of forage zone, which results in seasonal variations of fish aggregations. So like the study I show you already showed that the variability in the oceanographic conditions influence aggregation area of the Indian mackerel spatially and temporally. So therefore, integration of satellite data, GIS and statistical analysis combined with your in situ, that means your fishing location, observation related to fisheries abundance are the most effective ways to manage fisheries at sustainable level. Okay, so next. Okay, so now we know that the climate change will affect our food, right? So what are the solutions that we can do? So in the global solutions, I think the most effective way to deal with these challenges is to reduce our carbon dioxide emissions. So nowadays they use more electrical vehicle to reduce the carbon emissions. And for us and also everybody in our society, we can contribute by putting pressure to our government to demand action in order to achieve what is needed to reducing the carbon emissions. And the world has set a long-term target on the extent of the marine protected area. So you know that marine protected area is a very important area because it will help you to combat the climate change. So it set the goal of having 10% of the world ocean protected by 2020. Okay, before this, only 10%. But right now, we have the 30 by 30 goal. So that means 30 by 30 refer to the effort by the global community to conserve at least 30%, okay, of the terrestrial and the marine habitat by 2037 and 50% by 2044. Okay, next. Okay, that one is the global solutions. How about the local solutions? Okay, there are also local actions that we can implement to buy some time before this bigger scale carbon mitigation solution can take their effect. So we know that maintaining a good habitat, okay, restoring our coastal vegetations, eliminating overfishing, mitigating pollution, we can improve the overall status of the ecosystem and fish stocks. That means stop deforestation your mangrove area, protect your coral reef area. Okay, so also with regard to fisheries, try to reduce fishing pressure would be a major step, okay, to increase the capacity of the fish stocks in order for the fish to adapt to the environmental changes. Okay, so this will add capacity of the fish stocks and marine ecosystem to adapt and to respond to the changing ocean. So effort to reduce these capture stresses are crucial in addressing this issue related to the sustainability of the tropical marine fisheries and ecosystem by taking into account the impact of climate change as one of the anthropogenic components. So that's all for today's lecture. I hope that you understand. Okay, it's so long lecture. Okay, is there any question? Before we end the session?
You have one question,
I have a question
in call message.
Okay. From Wirastika. Okay, she asks, I would like to ask, is there any different result if you use only GM analysis without GLM to predict species present? And if you continue time series from the past 5 years. In JLM is different. JLM is only to check whether a linear, non-linear relationship, but JM more complex. Usually in other studies, they will use both, okay? But some studies also, they will compare JLM, JM to machine learning. So each will produce different results, okay? So that's why you need to see which your data set will suitable for which statistical analysis. That's why I show you the comparisons of the modeling, so you can know which one your data will have what you can use so that you can get the better results. Okay, you need to see your database. Is it 1 year? Is it 2 years? 5 years? So 5 years, that means you have a very large data. So maybe machine learning will become more effective than using JM or JLM. So like the study from Nudin, the data is only 1 year. So that's why he used JLM and JM. So if you have a time series data, 5 years, that means it's more complex. So better use machine learning. Okay, so Alin, I would like to ask, is there any risk of bias in machine learning used to monitor fish stock, and how might this bias impact the accuracy of the stock assessment, decision-making processes, and the livelihood of the local fishing communities? Bias, what type of bias you mean? So because in the machine learning, especially for random forest and VRT, they will give you a different, how to say, very complicated, different tree, right? You know, machine learning have many, they give you many options. So you need to know which one. That's why I say in the VRT, it needs a tuning. You need to know which tuning for your data, something like that. Okay, it's very difficult to explain in general unless you're doing the machine learning. Yeah. And so how they affect the stock assessment? So that's why it depends on your tuning of your data. So if your accuracy is high, usually you won't get 100%. Usually maybe around 75 and above to maybe 90. Okay, 100% is a bit very difficult. Okay. Is there any more question?
Vianta.
Okay, thank you, Sir and Dr. Yeny. Sorry, I can't turn on the camera because I attending two meetings here, and I like your presentation because it's related to my dissertation topic. But I have a 3 questions for you.
Okay.
In your presentation, I only see economic fisheries, commercial fisheries such as mackerel and tuna. And how about dolphin fish in your country? Dolphin fish are mahi-mahi or dorado or Coryphai nahipurus. Okay, and then a second question. Besides sea surface temperature, sea surface height, and chlorophyll A, what's the most important parameter that influence species distributions? And then for my third question is, in my dissertations, there will be make or build species distribution models using deep learning, such as artificial neural network on convolutional neural network, and machine learning approach like Maxen, and which will be used to site selection for marine culture. And I wanted to ask, how you performs when we compare theirs, and are there any tips or suggestions that can be shared for me? Thank you.
Okay, thank you, Bianta. So for the first question, Bianta asked about marine mammals, right? Correct? Dolphin, mahi-mahi, something like that. Okay. So for my study, we use for pelagic species. That means we can predict the schooling of the fish. Okay, so that means we need a data from the fishermen. So how much they catch per one trip or per one day. That's why we use catch per unit effort. But for marine organism, we don't catch them in abundance. So that means maybe what we can do is your observation, whether presence or absence data tadi. That means if you inside that location, contohnya you nampak ada mahi-mahi di satu kawasan ini. So that's your location. And then you see mahi-mahi in other locations. That means you have these separate locations. So itu presence and absence data. So maybe you can use that data also to make your prediction. Why the fish is here and why the fish is there. So applicationnya sama, cumanya dalam my studies is because kita pakai abundance. Kita pakai biomass, kita pakai berat. Okay, jadi for marine organism, kita tak tangkap, we just observe. So it's either ada or tak ada. So masih boleh. Okay, buat prediction. So maybe why the fish migrate here, because of the current or because of the wind or because of the SST. Okay, so same application. Okay, so that is question number 1. For question number 2, why we use SST, chlorophyll and SSH? Or you ask which one? Okay, so like I said, usually most study, semua kajian akan at least menggunakan dua ini, SST dan chlorophyll. Okay, tapi itu basic lah dua ni. But sometimes more complicated or more complex studies, they will use many variables. Okay, dia akan tambah wind, dia akan tambah sea surface salinity, dia akan tambah sea surface height. So when they have many variables, they will use more complex statistical analysis ni tadi. Dia akan menunjukkan which variable, di mana banyak-banyak variable ni tadi, ada 5-6 variable, which variable yang paling tinggi effect dia pada abundance ikan tu tadi. It will comes up with like a percentage. For example, SST influence 50%, chlorophyll influence 20%, wind or current influence this type of percent. Depending on your model, but most model will show you the range and also which variable that contribute most to the environment vector, to the catch tadi. Okay, for number 3, you asked about neural network kan? Okay, neural network, I'm not very familiar because saya tak guna neural network, tapi MaxN pun boleh digunakan. For my studies, I only familiar with random forest, BRT and also MaxN. Neural network mungkin boleh, cumanya saya tak pernah tengok lagi. Maybe saya belum baca. Okay, so advice. Mungkin this is the last questions I can take. So advice, so if you're doing a modeling, satu, it can get very tiring. Okay, you cuba model ni mungkin tak jadi, cuba model ni mungkin tak jadi. So in my case also, I tried many times. That means because you using R kan, your competency. So it takes a lot of time to try and error. So if hari ini tak jadi, besok boleh try lagi until you get the best fit for your studies result, AUCU. Okay, so don't give up. It's getting tiring, tapi jangan give up, because every fail, hari ni tak jadi, esok tak jadi, is actually it leads you to the result that you want. Okay, sebab you akan main dengan modeling. So modeling ni very complicated because ada banyak script kan. Yeah, you need to try and error, that's why. So itu sahaja. I think thank you very much for your time, because lama kan, almost 2 hours, and thank you. Mungkin ada yang belum makan lagi, so boleh makan dan boleh rehat, boleh tidur. Alright, I would like to thank Dr. Bambang for the opportunity. Terima kasih. Okay, and then I see you again maybe insyaAllah in other place and time. Slide ni boleh di-share, Dr. Bambang boleh share, okay, for the student to refer as well. Alright, thank you everyone. Terima kasih.
Thank you, Dr. Yeny, for the presentation and discussion session.
Okay.
You're welcome.
I hope everyone understand. Thank you very much.
Thank you, Dr. Yeny. Thank you for you all for your vision and question. Yeah, once again, I would like to thank you very much for your lecture. Very interesting. Yeah. But we still have one task, which is to publish the paper. Yeah.
Yes.
Yeah. Okay, we will discuss further about it later. Okay. Thank you very much.
Alright.
Shall we give
Thank you,
applause
everyone.
before we?
Good night.
Thank you very much.